It's just draft physics video production. Here it is. You arrived and such. Arrived. Can't even talk. So anyway, yeah, just haven't done it in a little while, so I'm out of practice. So we'll do some comments and then some maybe Faraday and Maxwell stuff, or maybe the Einstein stuff. I don't know. See where I go. Anyway, 2 reasons I stopped watching your videos before the 5 minute mark. You know, so how's somebody supposed to react to that statement? You can't listen to the whole argument. Uh, it's nothing to say, except, well, that's what an ignorant person does. Anyway, first and to the front, you speak way too unkindly about Ken. Oh, like Ken doesn't earn that? I mean, frankly, he's obnoxious. I mean, overtly obnoxious, and he only is obnoxious to essentially dead people or midgets or whatever. He doesn't pick on anybody his own size. Ha 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 ha. He's a fucking physics bully. All right. He doesn't play fair or any kind of stand-up kind of game. Right. He doesn't take on his adversaries at all. He doesn't even make his live rooms public, in the sense that you can't see what he says in those rooms. So yeah, coward. It's perfectly acceptable not to agree. Who cares? Well, I mean, it's really the primary function here on Earth. So saying you don't care about disagreement is kind of retarded. There's right ways to do things and wrong ways. There's right, correct physics and incorrect physics. And the whole point of Ken's channel or mine or anybody else's is to argue those points and to do it in some kind of way that is likely to have a result. And the way you don't have a result is when you argue with dead people. That doesn't work. Um, you know, it's not going to get any resolution because, again, it's such an unfair fight. And there's no honest interrogation. There's a process here, and the idea is through the process, good stuff rises to the top and the bad stuff sinks. That's the whole idea. So you have to have a structure of some kind where there's a give and take. And your hero is a coward, plainly. Unless you identify yourself by a brief structure. Well, I don't even know what the hell that could possibly mean. Some guy shows up here with a fucking cartoon as his frickin' icon and starts telling me I have to identify something. Fuck you. It's too silly. Alright, secondly, you are a spreader of misinformation. Well, you've got to prove that. See, that's the whole point. You prove something I've said to be inaccurate. You quote me, some kind of honest interaction. You just don't say shit like that without providing evidence of it. So you can't accuse somebody of being a pedophile, for example. Like, your icon looks like a pedophile. Your name sounds pedophile-y. So I should conclude you're a pedophile. Just call you one. And I won't even explain why I'm calling you one, because you have like a queer kind of icon and your name is weird. So I don't even give you the evidence I've used. And that's how you want to play the game. That's how your hero plays the game. I mean, you talk about grotesque and misinformation. I mean, he makes claims that he never supports with evidence, and then when he does cite some sort of experiment that you can do, he doesn't do the experiment, even though it's really simple. Why doesn't he do the experiment so simple? Show everybody. Because he's a fraud and a fake. Alright. Within the short clip I watched, I noticed a couple of perception errors, whatever the hell those are. So, more vague reference to some mistake or some flaw that you can't put into any kind of construct and explain and cite in any way whatsoever. Just such bullshit. I see that you have crooked eyes and therefore you can't see straight. What the hell are you talking about? Which is why, at least to the point I observe, that you are close but no cigar. So this is even funny. Like, he is the guy who's the authority. He can tell what is a cigar and what isn't, or what's worthy of cigaring. Just more preposterous arrogance from fucktards who have no credibility. They have done nothing to demonstrate any knowledge of any of these subjects whatsoever, and yet they speak as if they know the truth. Amazing. You speak in axioms. Well, that's all we have. Yeah, is you have to build everything on word associations and the connection between words. You know that this angle is half of that angle. You know, that kind of 2 plus 2, 1 plus 1. That's the only kind of terminology we have. So you have to have some kind of starting point. That there's the idea of a straight line and the idea of a circle. You know, and then you can start, making other shapes. But there is no logical backing up of your statements. No, there's no evidence backing up your statements. Absolutely zero. Zero evidence. And yes, there's a ton of evidence. The whole logical process is in my videos. You're just lying now, right? I mean, this is kind of like an overt lie, but there's no logical backing up your statements. Oh, sure there is. That's in every single video. I can replay my video if you want to get into a live room, and we'll replay one of my videos, and I'll point out all the places where I'm explaining my logical process. Because it's in every single video, asshole. Alright, anyway. That's not being axioms at all. So again, axioms don't need logical defense. That's the whole point of them. Is there starting points where you say, oh, we really don't have to go all the way back to kindergarten and explain A, B, C, D when we talk about words like hyperboloid or I know it's Faraday used some other word, vort or whatever. He's recognizing the fact that the donut shape isn't really a donut shape, so I guess he's calling it some other burloid. The field lines aren't circular. Jeez, people are just so annoying. But just what crap. I will add to this that we all spread what we think is true. Well, again, that's not the point. I'm here to have the argument. You're all cowards. That's the fact, right? The room's open, okay? I'll do a live room with anybody willing to speak some sort of English and make some sort of coherent argument. But if all you're going to do is say my hair looks bad, then yeah, fuck, you're out of the room. But if you have some competence, some capacity to articulate and explain where you've found a single flaw in what I've said, and I'll even accept even a single one, in the sense that it just can't be that way, blah, 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 by some kind of evidence. Anyway, so this isn't about spreading anything. It's about arguing it. The whole point is to fight for the truth, to put it out there and say it works, it functions. Go ahead, try to point out how it doesn't work. So I've presented a model, and now I'm saying, show me where it doesn't work. It can't be right. I cannot blame you for doing that except for the energy in which it was done. Well, I can't even, there's no hope of making any sense out of that. Fuck you, whatever that is. There's no shame in being wrong. Well, there is shame in being wrong when you're an arrogant, ignorant shit for brain who thinks I'm a very good driver. You're a fucking retard out of fucking control. And somebody ought to slap you down. That is, somebody ought to humiliate you deeply so you understand that, no, you're not a very good driver. You're not a very good physicist. You're not a very good scientist. You're not a very good thinker. You're not a very good person who plays in the game of logic. Because there's no logic in your argument. You're a shitty lawyer. Okay? You're a shyster. That's all you are. You have no credibility, no integrity. You're not fighting for the truth. You're fighting for your guilty client. And that's all you're doing. You're a piece of scum. So there should be shame in being scum about a thing or not having enough perspective to fully comprehend. So again, more of this nonsense that, oh, it's simplex, but you'll never be able to comprehend it with just like being educated. Having knowledge of experiments won't help you any, because it's all magical crap. That's right. That your whole fucking concept of reality is just based on what you want it to be, not what the evidence points to. I live my life in many arenas. No, yeah, like you haven't done anything. You've what? Stuck your finger in your nose, stuck your finger in your ass. That's all you've done in your life. To the level of my ignorance in the vast scheme of things. I've lived my life in many arenas knowing the level of my ignorance in the vast scheme of things. Right, so you're saying I'm ignorant. I'm not saying I'm ignorant. I've done a lot of work to gain knowledge of the subjects I'm talking about. I spend time thinking and drawing pictures and doing all kinds of stuff, whether it's philosophy or whether it's physics. Thinking through. A lot of work. So I'm not admitting any fucking ignorance at all. I'm admitting I'm ready for the fight because I'm armed and ready and I've prepared for it. You're completely unprepared and yet you're making all these bold statements and you're merely doing it because we've created a civilization where cowards like you are allowed to open their fucking gobs and spout their stupid idiotic accusations with no integrity behind them because we're not allowed to properly humiliate you. All right. If you choose to respond, I will watch the video in its entirety. Why? You think the whole video is going to be about you? See, you're just so fucking deluded. No, the rest of the video will be the same as the video you just said you couldn't watch 5 minutes of. It'll be the same thing. It'll be compiling evidence pointing out how your hero is a big, fat, cowardly liar. Yeah. Alright. And reply with any remarks you may have. That makes fun. That's so. I mean, he's obviously not an English speaker. If you choose, well, I can't say obviously because English speakers can't speak English. If you choose to respond, I will watch the video in its entirety and reply with any remarks you may have. Yeah, well, you can't reply with my remarks. That's plagiarism, asshole. I will say that it's good that you are getting your info out there, so to speak. Right, and you start the video with, I'm not going to watch anymore, I'm running away. You see, you can't even maintain any logical consistency even in a comment. You're already fucking backsliding and slipping out of your own words. Oh, so pitiful. Whether it true or not is the point. Yeah, that is the point. Let's see, out there, so to speak. A privilege for both posters and watchers. It's not. It comes down to nothing but harassment from you people. You're not making any points. You have nothing to say but shut up, but don't shut up. But you'll shut up, but I expect your right not to shut up. I mean, you're not saying anything. It's vacuous mush. You're just saying, I like Ken, and you're being mean to him. You're fucking childish. All right. Videos like these prompt skepticism, which is a great tool for learning. No, it really isn't. It's pointless if all you're doing is saying the man is wrong. Nothing's ever entirely right or wrong, and all that crap. You can go through this. The details is where the devil lives. That's where the real work is. So all of this crap that you can just throw things in these pigeonholes with your skepticism is bullshit. Your skepticism, like anything else, has to be reasonable. And people are completely unreasonable. And Kenton Wheeler is a fucking preposterous example of that with his fucking goddamn idiotic quotes about Einstein being an imbecile and all this other nonsense. It's just such fucking nonsense. The exaggerations are preposterously fucking trivially stupid. I mean, they're so obviously unreasonable statements. I hope this finds you well. I hope you fucking drop dead, frankly. I mean, you are the menace. You are the idiocracy. All these fucking mouths going blah, 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 with absolutely no knowledge of anything whatsoever except I like big, fat, bald tattoo guys. And that's all you're saying. I have a horny for a big, fat, tattooed, bald guy. And, I'm going to waste people's times arguing what a hero he is when he's a piece of fucking goddamn shit. He's an idiot. He, unlike Einstein, is an idiot. Enjoy your week. Well, don't enjoy yours, shithead. I mean, what is all this fucking pleasantries when you insult me? You fucking idiot. You think that's rational? You accuse me of all kinds of fucking misbehaviors, and yet you'll sit there and say this trivial crap to me like I'm supposed to say it's all alright? Well, fuck you. God, what an imbecile. Do you even read what you write, you fuckheads? Do you ever do that? You actually read it? I don't know why this always does this. It jumps way down the list. There really wasn't. There's only 2 comments, 3. Well, if you count this one. Yeah, alright. I love this shit, LOL. Okay, fine, whatever. Alright, so now this is Cliff, another defender of the Ken. Oh my fucking god, you're trying to debate... Ugh, these lights. A 2-minute video. Well, none of Ken's videos are 2 minutes, but whatever. But take 17 minutes to play the whole thing. And let's see you do it. Okay, let's see you take any old speech from a congressman or any other thing that goes on for maybe 10 minutes or 5 minutes of it, and that you fundamentally disagree with, and then show me how you would do it the right way, where you would essentially just let all the points that are wrong just fly right by. So you let the guy make 17 straw man axioms to state a bunch of false premises, and then you'll just chime in with, oh, I think he's wrong about that. Is that how you would do it? The point is Ken Wheeler, every sentence he speaks is full of garbage. So, in a sense, you should have to take a long time because there is so much crap to point out and say, look, he's giving you this as drinking water. Well, there's a piece of shit. There's some shit. There's some shit there. I'm just pointing out where there's so much shit in his water that he's providing. It's crap, okay? Everything he says is fundamentally crap. Now, the one thing he said that makes any sense at all is pressure mediation. Yes, that's true. I mean, his most recent video, right? I mean, he's so convoluted in his thinking. He basically says, you know, all these people looking for free energy are full of shit, and I'm not part of that, and it's all kind of crazy and stupid, and, well, yeah, I am working on a couple of ideas. I mean, it's just more contradiction. Yeah, we can figure out how to put a doorstop in, you know, open the door to energy, and it'll just keep flying in. So he points out how we already have free energy in the sense that we can already take advantage of energy, okay, in the form of, you know, the hydroelectric and the nuclear and the wind. And what do all those things have in common? See, if you think about all those things, and what's in common? Well, that's your pressure mediation thing. There's always more pressure somewhere, and you're letting it loose, or you're there's 2 sides: the sides where there isn't pressure and the side that is, and that you can take advantage of that differential, and that's energy. So energy is just imbalance. So when 2 forces are imbalanced, you can take advantage of that. And obviously in the nuclear sense, there's a lot of imbalance. You know, E equals mc squared amount of imbalance. In the sense that if you can find some way to screw with that little atom, there's a whole bunch of pressure, or lack of pressure, either way. You can think of it as an implosion or an explosion. But either way, there's a huge difference in the pressure. And so if you can cause it to become imbalanced, then you can take advantage of it. You know, like popping a balloon or something. There's some stored energy, some stored pressure. And it doesn't do anything energetic until you create the transition from, you know, imbalance to balance. And that's all you're looking for, is places where you can take advantage of the transition from imbalance to balance. And that's what the wind is doing, and the water's doing, and all the rest of the stuff is doing. It's seeking its balance, and it's taking time doing it, which gives us the advantage where it doesn't blow us up. But the nuclear one's a little trickier because, yeah, that one can blow us up, or burn us to death, or, you know, radiate us to death, do lots of things. Lots of ways for it to go wrong. But it's essentially free if you can control that transition from imbalance to balance. But you can have lots of energy in a system and it's balanced, and therefore you can't do anything with it until you blow up the pipe bomb. The pipe bomb is, you know, you can hammer nails with it, do whatever you want. It's unenergetic, you know, until you light the fuse. Alright, let's see. 2-minute video, 17 minutes to play the whole thing. Yeah, well, whatever. And that's the other thing I do is that I play whole arguments. I don't just take little clips. I don't quote mine. I don't do any of that horse shit. So I let people make their argument. So again, this is just such a fake response. And why don't you show me somebody doing it right? So anybody who says I'm doing it wrong, why don't you show me how it's done right? Show me the response video done the correct way. Okay, how can we have a chance of understanding what he and you are saying? Well, clearly the video is there for you to go watch. You can watch this video 6 times. I've watched many people's videos more than once. And so that's your prerogative. I don't need to watch Ken's videos, more than once because he says the same thing over and over and over again every single video. So this is another joke here, almost like you haven't paid any attention at all. How can we have a chance of understanding what he, right, is saying? What do you mean? He says it in every video. Same thing over and over again. What he and you is saying, if you stop at every 2 seconds to interject and abstract information you had loaded and ready to shoot off. So another pile of crap accusation, right? I mean, the only way I'm ready is in the sense that I've heard him say all this shit before, so you could say in that sense I was prepared, but most of the Ken Wheeler videos, I didn't watch the video first. Well, it's probably 50-50. And I certainly didn't sit there and waste much time thinking about what my response is going to be, because what he's saying is just such an exaggeration and such preposterous nonsense, in the sense that he just says, look, hyperboloid makes a magnet. Well, explain to me how that makes strong attraction and strong repulsion, because they haven't done any of that. Let us, and certainly show me how. Again, it doesn't take much work, okay? And I'm saying the videos are up in the internet. I've made a couple of them. I've shown the frickin' ferrofluid under a microscope. So I went to the trouble, put it under the microscope, played around with it with a magnet, and shown that it lines up just like little iron filings. No surprise at all. Takes a little time because it's in a fluid, blah 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 blah, but that's all that's happening, asshole. And all you're doing is reflecting light off of those little pieces, because they reflect light, and that's all that's happening. And there is no light bending anywhere. It's diffracting off of the surfaces. It's deflecting off of the surfaces, period. There's no magic to it. I mean, beyond the magic of anything that's illusionary. Any magic trick has a solution. Don't you understand that? No one actually pulls magical, spontaneous pigeons out of their sleeve. There's a mechanism. And there's a mechanism to the ferrocell, and it has nothing to do with any magical magnetic fields that are now doing swirly and loopy and curvy things. It's not what they're doing. They're doing what they always do, which is radiating. Alright, ready to shoot off because you were so angry with his video. I'm angry because the world is being run by liars and bullshitters and incompetence, and that sucks. And Ken Wheeler's just another example of it. He's supposed to be the anti-establishment, and he's just another establishment of dogma, another fucking religion. Let us watch the fucking thing. So this is so stupid. So nobody should make response videos, is what you're saying. Everybody should just be allowed to say their crap without anybody interjecting or explaining why it's crap. And if they're going to do that, what they should do is somehow, I don't know what, compile meticulous notes to go through every bit of context without playing the actual video. I mean, doesn't it make more sense for me to let Ken Wheeler say it than for me to quote it? What makes more sense? You're going to make are you going to really challenge me with the argument that it makes more sense for me to paraphrase his quotes than it is to let him say them right out of his own mouth? That somehow it's more fair for me to quote mine his videos than for me to play his video? God, you're really stupid. And have a chance of understanding what's being discussed here. Like, it can't be discussed because Ken Wheeler's a coward. Again, I'm all for the discussion. I'm all for Ken Wheeler answering questions directly stated, plainly stated, and it's your hero who's the fucking coward. Again, And for fuck's sake, get your microwave dinner out of the fucking microwave before filming. So just more nonsense about stuff that couldn't fucking matter to anybody with any kind of real brain, right? I mean, a beeping noise in the back because a cup of coffee's in the microwave. This bothers you people so much that you have to say something about it, like somehow it's really relevant. I mean, my shirt might not be perfectly symmetrical. Oh my God. Oh, I certainly haven't shaved. That's important to you, huh? Okay, yeah, sure. I'm sure it isn't important to you. I'm sure when Ken does it, it's okay. If Ken has some bullshit in his video, that's okay. Some distracting bullshit, it's okay. Oh, you people are just so pathetic. Ugh, just disgusting. Alright, so on to the Faraday stuff. I guess we'll do that first. So I was curious who used what phrase first, because I've tried to emphasize there's a huge difference in terms of understanding, I think, in understanding what a field line is. So I'll argue, okay, that we have two concepts. Now, I don't know if Faraday, I haven't found the stuff where he might have been dealing with electric charge and how he might have drawn that. See, you can't find any of this stuff on the internet, and it's really annoying, actually. I mean, I didn't realize how broken the system really was. But you can't find Maxwell's books or Faraday's books, certainly not in text form, and the best you can do is Google, and Google only shows you, like for the Faraday book, page 400 to page 485 or something. So I'm able to read the last, 100 pages, but the first 390 I don't get, or whatever, 400 and something, which is really annoying, because this is the basic stuff, and you think somebody would have, somebody who has the books, you think they could have just scanned them into their computer, and I mean, there's software that can, put it into regular text and do all that shit, and it's really not that much trouble. And so I had just no idea that all these really important books aren't online. You can't get the text of the book. It's just no audio books. Amazing. I'm listening to an Einstein audio book, and it's really almost irritating, because they have 17 different people reading the fucking book, and half of them are women with really soft voices, and it just doesn't work. But anyway, it's just a critique that it's really pretty annoying. That I didn't think the internet, I know the internet's broken, I didn't think it was that broken. Alright, but there's this idea of a point charge. Everything's pointing, point, and point just means that it's coming from something that can have a shape, but I mean, there's a center, and the idea is that there is no, everything's coming off these little points on the surface, or the point is basically the center of the object. But anyway, the idea of the field line, you have two concepts. Now, this one you see in Maxwell's drawings of charge, which is the important one, because this is Gauss, and this is the inverse square law, is the understanding that the force is radiating essentially, okay, from the center of the object. Now, it's reflecting off the surfaces, but it doesn't really matter in the sense that it's always on this line. And then you have, so those are one kind of line, and so in like Gauss's mathematics and stuff, the idea would be is that these lines inevitably, because it's coming from one point and it's spreading over a bigger surface, that these lines essentially are the force, and that they are diverging in two directions. They're not only getting further apart this way, they get further apart this way. And so that's the inverse square law. So that's where you get this r squared from. And Lorentz turns that into basically a function, okay, of a mathematical function that creates essentially an infinity here, okay, where you'll never get to zero effect. Now, as a practical matter, you could get to a zero effect in a sense. You could be something far enough from space, and as I've pointed out, I could have this light bulb in empty space, and I could put something way far away. And there are going to be places in space where the photon just will never get there, okay, because it just never produces a photon on that path. Or it does in, one every billion years. but it'll be a whole photon that hits it. So, I mean, the average is just an average. But anyway, this idea that this just goes forever, you just keep having and having and having, and you never really intersect here. So the distance, how much change in the force, that is how much hits you, it becomes irrelevant after a point. If you get 1 billion light years away, it just 2 billion light years is pretty much the same, and 4 billion and 10 billion, you know, the amount of photons hitting you, it just couldn't matter much. You know, it just becomes irrelevant. And it's very important how, you know, when you start off. So when you're close, there's lots of lines to play with. You can block lots of them, get hit by lots of photons. But as you go further away, it's half the distance, 4 times less. Just like this hand is 4 times bigger here than it is here. Okay. And so this is a function of light. So that gets to the Einstein thing. So this is something to remember, that okay, you can see the r squared of gravity this way, and it's not inaccurate. This is true. There's a whole lot of difference here, and as you get further away, the amount of difference becomes less and less and less and less and less. That's a real fact, so to speak. But there's always a chance that this photon leaving this light bulb could travel 15 billion light years, and even though there's a huge distance difference between, you know, way over there way over there, there's a huge amount of space that the photons have to fill, and it'll take them forever to maybe hit this exact spot. Forever, you know, you have to qualify that. I mean, it'll seem like an awful long time. It'll actually be once every billion years the photon actually hits the object. But you're just doing, it's just because of this. It's just because something that starts off in one place and it has to be spread on something much bigger. So you have to take this little tiny bit of something and you have to spread it across this whole thing. And you can't do that any other way than change the time. Okay, so time will decide when something hits it. How often it hits it is going to be critical, based on how long you have to wait. So if you wait long enough sitting right here, a photon will go to you. But the odds are it's going to go to all these other places, and it's going to take a while before one finally hits you, because they're spreading. And they're spreading in these 2 dimensions. And so that's where the inverse square law comes from. And that's the important thing to recognize, is there's the physical mechanism. All right, and that's the physical mechanism for gravity. All right, so I say again, just to reiterate, so these are lines you could draw from an object, okay? And this is done in the geometry of the math, and this is a real thing. So this is a kind of line right here, and then there's a kind, see, and you can actually, for your purpose of your calculation, if you make these number of lines, okay, mathematically useful, in the sense you pick a number like 10 lines, you can make your math much easier, okay, because you're just simulating a percentage, and so you're taking a number that's easy to play with and dividing it, where if you take some other number you end up with a bunch of fractions and it just gets a lot uglier. But anyway, so these are lines. Now, did anybody ever call these something is the question, because Faraday essentially is concerned with this line. So this line is the line you make because all of these forces are equal. There's the same likelihood of a photon hitting here as there is here, 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 because all these distances are the same. So as long as the distance is same, your likelihood of receiving a photon at all these locations is the same. And so this they call a line of force. Now Faraday does. Okay, now I'd call that a field line. So this is where I would make a distinction. I would say these lines are field lines. These lines are lines of force. Okay, but that's not what Faraday was doing. Now I don't know, Maxwell wrote after Faraday, so maybe Maxwell gets the terminology clearer in making a distinction between these 2 things. Because Faraday is basically saying these lines exist, you know, that the magnet makes these lines. And these lines, I'm saying, are completely arbitrary. They're the thing that you can put that line anywhere and it just doesn't matter, because what the magnet is doing, for example, is just telling you you're basically taking another magnet and saying, you know, how does the magnet turn in terms of the force differential. So I sort of have to make a dipole to illustrate that point, but I've already done that in videos, and it's in one of the playlists. There's one on lines of force, and so I don't need to go over that, I think, again and again. But I'm just saying it's a huge distinction, because this line is just arbitrary, and it's always going to be, in the case of the dipole, so let's draw it just for the hell of it. I mean, it's really important, you know, to understand what's happening, you know, in the sense that it's not what people make it into. So if I make the dipole, I make the electron and proton, again, I can make the dipole, the first smallest dipole, out of just an electron and a proton. And the idea is I take another magnet and I put it in this field. What's it going to do? And it just has to do with the fact that we know there's two different effects. That the opposites attract, the sames repel. So we know there's repulsion happening here, and then there's repulsion happening here between these two, and then there's attraction happening between, you know, this and this, and then there's attraction happening between this and this. And those forces are going to decide which way the magnet turns, and you can do it, you can understand it entirely by just recognizing that there's two forces mixing, okay, and you can understand just by doing it this way, and just say, just by those rules, these straight lines will give you those lines. Now let's understand that when this forms, it's going to form essentially an opposite magnet, right? This magnet's going to be opposite of this one. Okay, so this line of equal pressure, you know, even pressure, will be exactly the same as in this next one, will be exactly the same as that, and it'll be again opposite the first one. And just like in motors and other things, these are opposite magnets it creates. So when you have this spinning disc thing and magnets, you're creating an opposite magnetic field in the other thing. The other thing's becoming an opposite magnet. And if you have more than one layer of that opposite magnet, obviously these things are going to repel. These magnets are not going to be smashing into each other. They want to move into here. All of them want to go to this big magnet because they have the opposite arrangement. But they clearly hate each other. So the only thing creating the iron filing lines is the fact that these magnets are opposite magnets. The ones that form are opposite magnets, and opposite magnets can't be next to each other. So that's why you have this separation between these lines of force. They're not lines of force, they're just the lines that the magnets will line up on, and the fact that there are lines is just a consequence of the fact that they're all lining up as opposite magnets. This magnet is inducing magnetism, and the induced magnetism is the opposite of the original magnet. I did that backwards. It's the same as the opposite magnet. Oh, no, I didn't do it backwards. No, it's the opposite. But they're the same as each other, and that's the important fact. So once you stick one in here, you know, they all move into here if you didn't have a piece of paper in the way. If you didn't put some obstacle in the way, none of this stuff would stay here. It would all just fly into the magnet. And if you do that in fluid, you see that happens. I mean, the magnet just, I can draw it over here, you know. I mean, it gets just a bunch of clumps of the filings on each end of the magnet, you know. Just pretend that's red, and it just clumps on that end too. You don't get all these lines. All right, anyway. So I just want to make this distinction that the mathematics also clearly states Gauss's laws. You know, that the force, if you want to say there's a force in some location, so you pick a location in this field on one of these lines, right? So you take one of these lines and you put a charge on it. They'll tell you quite clearly the charge leaves parallel to the field line. Well, of course it leaves parallel because it's parallel means it's in alignment with the center of the gravity of the thing producing it. So it's exactly what you'd expect it to be, parallel. It's parallel to that center. In the case of a dipole, the center would be the center of the magnet, and it's going to be parallel to that center, and that's going to be the force. The place you would, if you, like I said, if you stuck something there, a negative charge, which way would it fly? It's always going to fly off parallel to the line, and that's because the line is essentially perpendicular to the center of the point charge, whether it's a dipole or not. Like I said, dipole just means you're mixing it evenly. So it's the even mixture is going to end up being the middle of the magnet somewhere, the center of its gravity, whatever you want to call it. Yeah, so that's probably enough on that. And yeah, so I'll think about moving on to the Lorentz stuff. So I'll be back. Alright, I'm back. Alright, instead, let's talk some more about Faraday's paradox. So this came up in the science chat, whatever the thing on Saturday morning is, and they had all kinds of audio problems. There's always something, you know, they just can't seem to do it in a very... Well, anyway, it's kind of an awful 2 hours to struggle through, and just part of my desperation for some sort of science talk that I tolerate how horrible it is. Anyway, but apparently there's some sort of paradox with this whole idea of spinning a disc over a magnet. So you just think of so you just got one face of the magnet, and then you spin a disc of copper above it, or you spin the magnet and they try to pick up a current off of it, like the eddy current, but that's sort of a waste of time in my opinion. You're not going to pick up those currents. But anyway, and then they have, you know, unfortunately they have wires. I should put them the other way, just because it's more like what they did, you know. All right, to pick up the current. Well, you can't do that in the first place. Second place, you always have to be aware too that there's already the Earth's magnetic field that you're turning something in. So whenever you're spinning something, you have to realize that if it is capable of becoming, if it is paramagnetic, that it will, you know, acquire a sympathetic magnetic field because you're moving it in a magnetic field. So, you know, you have to first isolate that as being a possible cause. So there's so many flaws in this experiment in the sense that these wires are really the problem. You know, they're in the inductive field. They're going to pick up a charge, and you know they have an amplifier on here and then an oscilloscope, and you know, so they're amplifying a tiny voltage into a big voltage, and you know it's just doomed to failure. So the idea is they spin just the magnet, and nothing happens. I think that's the way it works. And then they spin just the copper disc, and well, they spin both of them. There's a field. Well, the point is when they just move the wires, they pick up the signal, which is obviously the point is the wires are inductors and they're doing the work. So when they're moving the brushes, but the point is when they move the brushes, they move the wires, and it's the wires moving through the magnetic field is picking up the current. So you can see obvious flaws in the experiment. But what I would argue is what you have to realize is that when this new magnetic field is created, it is the opposite field. So what's happening is you're changing this surface, and so it's the opposite magnet now on this other side. And so now you do have a magnet in this big sense. You have a magnet looking like this across both of them, right? In the sense that now this one's going to be green again. So, you know, it has this little red piece and then it has the green piece. So you can sort of get that it's not lined up properly because it has two north ends. Because these essentially become repulsive to each other. This spinning disc would levitate if you gave it enough spin. Because they're opposite. It's an opposite magnetic field. So now you're exposing the wires to a dipole field in the sense it's getting this, and then it's getting this, which is the opposite field. You know, I didn't draw that opposite enough. So it's now you have a dipole field that you're spinning, which is a lot different than a monopole field. or just the north end being exposed. The other thing is obviously the disk is bigger than the magnet, which just creates another problem where it's getting exposed on the edges to the other side of the magnet. It's sensing the dipole. So if you make your disk bigger than your magnet, then this green stuff starts getting on the disk also, and that's another place for erroneous results. But I just wanted to make that point that so when you spin both of them too, when you spin just the magnet, the magnet's creating a field here, but again you're creating a new magnetic field here that's the opposite of the one down here, and those two can just cancel each other out. So that's part of the problem. But yeah, just understand this face is going negative, and the point is as I've sort of argued, is to create the eddy current, or whatever you want, the electrical effect. The whole idea is you need to expose the atoms in a way where they change quickly. So they take time to change, and so the idea is that you're exposing the atoms to the field. So they're getting hit by radiation that's going to flip them, so to speak. It's going to change them, and the idea is if you change one and it hasn't changed and it hasn't had time to move the electricity, so it's still that color, you don't want to hit it again and again and again while it's red, because then it's just going to reflect it back. So nothing important will happen. But if you hit it when it's in this condition, then you can change it. If you hit it in this condition, you can change it. And you can hit it in this condition, you can change it. So if it hasn't, through the conductor, gone back to green yet, you're just reflecting the energy back. Where if you hit it, you want to hit it before that can happen. To get as many atoms in to polarize, so you got to get the thing that the atoms are what you want. You want the most atoms possible to polarize. You don't want them to polarize this way or this way. You don't want them to exchange their energy in these directions, because then they become dipoles. The whole point is to make as many magnets as you can in this orientation, and to make as few as possible in this orientation. Alright? That's the real key to making the thing work, is that if you have the mixed magnets, then you go back to nothing, right? No effect. There's no magnetism in a magnet that has its domains all pointing in different directions. It becomes non-magnetic. So as soon as you start making magnets in the wrong direction, in counter directions, you're decreasing the amount of magnetism. So it's really just about whatever you want to call these eddy currents, or essentially the creation, the transmission of the polarity in a direction. And you want the current to be moving in one direction. You want the transition from positive to negative to move in one direction, because that'll mean the dipoles are all in one direction. That's the point. Yeah, so that's the thing to take away from it. The important thing to take away from it is the fact that you're making dipoles in one direction to make an effect that you can measure. Alright. That's close enough. Alright, now onto the little Einstein bit. While we're on the Lorentz stuff. So they call these transformations, when you take the mathematics and you figure out that, there's a couple of these, we have factors of distance, something travels, and then you have distance, and then you have velocity in a direction, and distance, and velocity, I should have said. So you got a couple of variables that you can view from different points of view. You could see something from here looking at it this way, and it has a length like that, and then or you could look at it this way, and then its length is going to appear smaller, because it's further away. Now this gets to the whole inverse square law. So Galilean transformations just are dealing with the fact that as something is moving perpendicular to you, its size changes, going away going this way. And so you can make a transformation, a mathematical gimmick that'll explain how that happens. And it'll have a curve like this Lorentz thing that kind of just explains the more you go over this way, the smaller and smaller it gets by a smaller and smaller percentage. But it's more percentage of change in size right at the beginning than at the end. So that's where this comes from, this idea of the curved line. And so for all Einstein did was pretend, okay, that to make these things equal. So what you're really doing is just trying to equal two circumstances. So in one circumstance you're seeing this distance with a velocity, in the other circumstance you're seeing this much distance with the same velocity, and you're trying to make those two equal. So you just create this transformation that makes them equal. Now Galileo didn't do it by creating some time dimension, but Einstein did. So the difference is, so what Einstein did was take something that's optically a truth. Okay, light does do the inverse square law, so optically that's a reality. And what he did was say, we're just going to say that we're going to make this transformation not out of some imaginary x, a fake thing just to make the numbers match. We're going to do it with a thing we're going to say is real, which is time. So we're going to make time the fourth dimension and allow it to create this inverse square law relationship. And so the way we're going to make these two things the same is we're going to say time changed. And so by multiplying these things by a time factor, we're just going to say that, okay, this variable is the same, the way we measure distance is the same, stays the same, so the velocity and the distance stay the same, and what we're going to make the new wacky number is this t number. So now we can make the t number, okay, so say this is 4 feet and this measures out to 15 feet. We're going to make the t number the thing that balances those numbers and makes them equal. So now we're going to make 4 feet equal 15 feet by just creating a t number that works to compensate for the difference. And the t number does the inverse square law conveniently. So instead of something logical like saying, well, whatever this factor is, it should be proportional. That is, it should be this kind of line. Half the distance, half the intensity, so, that kind of thing. Now they have the time dimension that they're going to put on this line, and now they're going to inverse square law. They're going to say time is like light, okay, and it's moving in two dimensions, separating, degrading, changing, and then they come up with essentially that line. They just do the same thing, they just do it in inverse. So now you start here and you go to infinity this way. So they just took this and turned it up the other way, and so they're saying time dilates at the same rate as light separates. So I'm just saying, we know the mechanical cause of this. I mean, at least you should be able to say, yeah, I understand, that's this whole circle thing. I mean, it works for gravity and it works for light for a reason, because they're point source, because they come from essentially what could just be described as one tiny little point, and they're spreading out to a big giant circumference. And that's why the inverse square law exists. So that has a mechanical function. This has no mechanical function. This is just an arbitrary bullshit where they've decided to take a real thing, time, and make it their fudge number, the number that makes two things that aren't equal equal. Two things that you understand are the same in the actual reality, but you're perceiving them different, so you're coming up with a fix for your broken perception. In the sense, you're finding a point in between the 2 points that is the right way to look at it. You got somebody looking at it from the left and somebody looking at it from the right, and you're basically mathematically figuring out what it would look like from the center. So this one has some reasonableness where this just doesn't have any at all. And so then Einstein cites different experiments, and I just thought that was incredibly curious also, as an indication that he's on the right track or something. Like somehow this is allowed, or this is the way it has to be, or this is... And one of them has to do with fluid, which I thought was really interesting. So let's say you take a transparent fluid and you pump it through a pipe, and then you shine light into it. So you're shining photons into a fluid that's moving, a transparent fluid. And the idea is, how long does it take for the light to get here? Okay. And you could just logically say, well, it's got to take longer because you're essentially making this amount of distance in terms of mass the light has to travel through. So we know light takes longer to get through water or glass than it would take if it was just going through nothing, because it is interacting with the material. It's hitting stuff. It's not going through empty space. It's hitting electrons. Electrons move slower than the light, blah 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 blah. So it's essentially taking a crooked path to get through the substance. And hold on a second. Alright, I'm back. Finishing up and such. Probably. Let's hope. So anyway, I just thought that was an interesting experiment. So what you're basically doing by moving the fluid, and I guess they might have done it both ways. I don't know. I have to find this experiment. It'd be interesting. Obviously you're just kind of making the amount of atoms that you're subjecting the light to, you're just increasing the number of atoms. So essentially you're taking something that might be 1 foot of substance, and you're changing it into 3 feet of substance. By moving the substance towards the light, you're forcing it to interact with more atoms, and so you're just basically increasing the distance by increasing the number of atoms. And so Einstein's using that as evidence of this theory of time dilation, and you're like, that's a lousy evidence because this is clearly a fluid, a medium. He hasn't defined this medium of bent space as a medium that you can move and that it would be harder for the light to get through it or something like that. So there has no parallel. You're clearly going to get a similar line. You'll get a similar effect in the sense that you will. But I'm sure the effect is going to be, it's not going to have any Lorentzness to it at all. It's going to have a real one-to-one relationship. So instead of getting any kind of Lorentz kind of image of the increase in the length here, so this length will not increase by some sort of Lorentz number. It'll increase by the straight line. So instead of the graph looking like that, the graph's going to look like this. It's just going to be proportional. So the faster you make you put twice as much fluid per whatever square inch or whatever, you'll get twice as much degrade in the progress of the photons through the increased number of encounters it's going to have with the medium. Now the idea would be is that theoretically the light, so let me think through this one. So if we were to think about what the light's going to be doing, the idea would be the light goes in, it moves the speed of light, and when it hits an atom, the catch will be it'll take it longer because it has to move the electrons. So the force, essentially is the light, is interacting with electrons that move much slower, and that's a certain percentage of the time it'll spend engaged in the electron. But that percentage, you can only throw so many electrons in the distance. So even if you have the electrons, you're moving more and more atoms in, the amount of proportion of the time you have to hit those are dependent on how much progress you're making through the material. So as you go through the material, your chances of hitting more atoms gets less and less and less as you get through the material. So it probably might have some sort of Lorentz kind of factor, in the sense that you can't, it's just like the mass argument, the gaining, all these arguments can be, I guess the point I would make is they can all be explained by other mechanisms. So just like they say the mass increases as you increase the velocity of something, I can say exactly the opposite is happening. As you're increasing velocity, you're taking noise out of something. So it has stuff going in different directions in it, and then you start giving it velocity, it means it's changed, and that means more of its force is going in one direction, and that means you can't hit the stuff going in the right direction, so there's less stuff going the wrong way. So where there was 10 things going the wrong way here, as I increase its speed, that changes to 7 things, and then to 6 things, and then to 5. And as I'm changing that, that means there's less likelihood of an interaction with the object, any kind of interaction at all. And so it's becoming more and more transparent. So the point is that it's not harder to push because it got heavier, because it's got more energy in it. There's not more energy or more stuff to move, more mass. There's not more mass in the object. There's the same amount of mass. It's just that the mass is now moving in the same direction as the force you're applying, and you can't apply force to force. You can't apply force to a force that's already going in the same direction as you. You can't make it go any faster. Obviously, you can't even hit it, is the point. And so there's less for you to hit. You can only hit the stuff going the wrong way. So the rule is, stuff going this way you can't hit. You have to hit stuff going this way or going against you, but you can't hit stuff going the same way you're going. So the more stuff going the same way, the less there is to hit. And in essence, it's a lack of mass. So the object essentially with velocity isn't getting heavier, it's getting lighter. And that's why it's harder and harder to hit. It's because it's losing atomic structure, and the atomic structure is the only thing you can hit in a sense. It's losing stuff for you to hit. And obviously when it's going the speed of light and everything's moving the same direction, you obviously can't hit it, because the only force you got to use is going the speed of light. So obviously you can't hit it with something going the speed of light because it's already ahead of you and you'll never catch up to it. And so that's why there's a termination. So again, then there's a termination. There's a point where all of the bits are moving. So by Einstein's theory, that never happens. All of the stuff inside of here can never go all the same direction. So he just makes this arbitrary rule that it has to go to infinity. When, of course, logically, you could understand if there's 20 seats in the boat and they're all going the same way, then that's the way the boat's going, and your boat can never catch up to it, because your boat can only have all of its seats going 20 the same way. So you can never apply a force to it. You can never hit it. Your bumper car can never catch the bumper car going the same speed as you. You'll never bump into it. So in a sense, the thing gets lighter. But it's just, I'm saying you can draw either conclusion. The evidence doesn't provide any clear demonstration of one mechanism being right and one mechanism being wrong. There's no evidence of that in these superficial similarities. Like I said, the reason why this has a similarity to an inverse square relationship is because the further you get into it, the less of it there is for it to cause you trouble. And the only place you cause trouble is for one moment, and there's only a certain number of possible moments. So there's a certain number of dashed lines you can possibly encounter. In a sense, there's only a certain amount of space between the atoms. So essentially, the faster you move the fluid, you've just created a fluid that has more density of atoms, and so you've just made sure that every photon never goes through any free space before it hits an atom. So the idea is to think in terms of how far can the photon travel before it hits an atom, and then how far can it travel before it hits an atom, and then how far before it hits an atom. Well, there's a limitation to how many atoms you can put in here, and once you've reached that limitation, you won't go any higher. So they'll never have that same kind of curve, because if I make it go fast enough, it'll be as if each atom was right next to each other and there's no free space. So the photon will never travel empty space. It'll always be forced to travel into another electron. So it'll go from moving an electron to moving an electron to moving an electron, rather than going from moving electron, free space, moving electron, free space, moving electron, free space. Well, anyway, it's probably a little more complicated to do in this superficial way, but I mean, the idea is probably a little, but I'm just saying that's all. Einstein's rubbish just has to do with this Lorentz crap, and he's clear about that. If it wasn't for Lorentz's blah blah blah, and it came from Maxwell, so it clearly came from the fact that that's what light does. Light diverges in two directions, and they've essentially made this time dimension do the same thing. Time apparently obeys the inverse square law for no good reason. I mean, no logical reason. And yeah, that's all there is. So there's no logic behind the fact that they say all of the time variance happens when you get really close to the speed of light. There's no logic that forces that to be the truth, is the point I'm trying to make. And the only logic we have is the fact that obviously there is a progression as you change the form of the matter, making it go faster and faster. But again, there's no reason for that to be, it won't have any Lorentz aspect. It won't go for infinity in a direction. The very fact that they create some mathematical mechanism that ends up creating infinities should be kind of a giveaway that there's something wrong with that physics. But anyway, enough said. It is right in the case of the photon, because the infinity is just a recognition, not that it doesn't happen, but that it happens, that it can happen so distant from, so distant a place. You could go as far as you want to in the universe. I can make the universe as big as I want, and there's always a chance that one of the photons from the light bulb will get there. I mean, it might only happen in some preposterous huge amount of time, but it could happen. Alright, anyway, enough. So, oh yeah, the other thing I wanted to say about this experiment was they have a part 2, and they really screw it up by doing that. Okay, so they take a whole thing and put a coil inside with a magnet spinning inside the coil, and then spin that whole thing. And you can't do that, because that's clearly going to cut across, okay, the magnetic field of the Earth. So you're clearly going to create, just spinning a big coil will create a current in wire. So you can't spin a coil and expect there to be no results, even regardless of what you have inside, whether you have magnets, spinning discs, all that kind of crap. You can't spin a coil. So of course you're going to get a current in the wire when you're spinning the whole device, because you're spinning the coil. Anyway, these experiments are, they cause more confusion than they do clarity, because of the poor way they're done in terms of not eliminating, the control. Take each element of it and do it separately and see what it does before you combine a bunch of elements and then say this is how they're interacting, because you haven't figured out the fact that they're already interacting in ways you didn't anticipate. Like I said, by turning a coil in the magnetic field of the Earth, you're going to create a current. Alright, anyway, enough. So, until the next time and such. So forth and whatnot. Yeah, that's good enough. Mostly. Yeah. I got an email from some guy who was saying he didn't like the changes I made to the way the electron and proton reflect energy, and yeah, I haven't made any real hard changes. I'm just saying keep it simple. Start with the simplest diagram first, and then see what you can make out of it. So it's just wait on the simulation and then tweak it. So anyway, yeah, I'll get to your email is what I'm saying essentially. Just not yet, because I'm still working on it.